Okay, guys, I'm going to do some homework from section 2.4. So let me pull that up. Let's see. I'm not going to go over all of the assignments, just ones I think you might have trouble with, or kind of quickly do a recap. So here we have, does a limit exist using this graph? The big idea is when you see that little tiny plus or that little tiny minus, what does that mean? Do you remember? It means from the right if there's a plus, and it means from the left if there is a minus. So we have plus here. So it means you get on C, it says C is -1. All right, so that's labeled right here. Your C value might be different. Mine's -1, and I'm saying, okay, I get on the right side of C. So I'm on this side, I approach C, I come and I'm approaching that Y value. The Y value is -3. In this case, since the function's continuous, these are all going to have the same number, -3, -3, -3, because these are the same. If these were different, then the answer would be does not exist. Let's move down. Is the function continuous? Yes, because we have a value, we have a limit, and we have that the limit and the value are the same thing. And also just intuitively, you don't have to pick up your pencil. Use the graph to determine if this limit exists. Okay, so from the right of C, my C is -3 in this example. I get on the right side. Here's -3. I'm on the right side here, which is this line segment. I'm approaching that open circle, which is at 3. From the left is 3. But what is the limit overall? It's actually also 3, because that's where these are both approaching this open circle, which is at 3. But this function is not continuous because of that third reason. The limit as x approaches -3 does not equal the actual output at -3. That means this circle up here. This circle is at 5, and this one is at 3, and 3 does not equal 5. So this function is not continuous. So let me move down. Let's see. From the right, we're approaching -4. From the left, 4. It's not continuous. So let's talk about this one. 5 from the right. In this case, there's no problem. When you plug in 5, it's the only problem is going to be when this equals 0. And what would make the bottom 0 is x equals -5, not 5. So you can plug 5 in and you get 1 over 5 plus 5, which is 4 over 10, which simplifies to be to this. Find the limit if it exists. Okay, let's go ahead and see what happens here. If I plug in 5 here, I get 25 and I get 0. I get 0 over 0, which means there's more work to do. And this is a difference of squares. So I'm going to factor. The bottom factors to be x minus 5 times x plus 5. And if you remember from last lecture, this tells you what you're trying to get rid of, x minus that thing. I know it has from the right here, but this one's going to be the same both ways because we're going to be able to remove this discontinuity. It's a hole in the graph. And the way we can remove it is we notice that this here and this here are almost the same. I just need to pull out a negative, all right? And if I pull out a negative, that would make this a -5 and this a plus x, which makes this factor x minus 5 and this factor x minus 5. They're just written in a different order. So these simplify to be a -1. So I have -1 over x plus 5 is another way to look at this function. And I'm going to now be able to plug in 5 without a problem. X is approaching 5 from the right or left doesn't matter. They're both the same here because you get a numerical answer. So -1 over 10. This one, if I plug in -4, I'm going to get a number over 0, which means that the function doesn't exist. So you could just go ahead and say the limit doesn't exist. It's going to be positive or negative infinity, but you know if you get a number on top and 0 on the bottom, it's no, there is no answer, it doesn't exist. Find the limit if it exists. If the answer does not exist, enter d/any. So if I plug in 3 from the right, if you remember we did examples like this. So the absolute value of x minus 3, what happens is it's a piecewise function. And is negative x minus 3 if x is less than 3, where this equals 0. And it's positive x minus 3 if x is greater than or equal to 3. but we're writing it as this function. We're dividing by x minus 3. So if I divide each of these guys by x minus 3, I am getting -1 on the left side and +1 on the right side. So this looks like this. Does the limit exist at 3? No, but it says the limit from the right of 3. So I can talk about the one-sided limit. The one-sided limit is on this side and it's approaching +1. The left-sided limit would be approaching down here, which would be -1. This one, if you remember, how do we figure out if they exist? We plug 8 into both of those functions and we see if they're equal to each other. So does 8 squared minus 4 times 8 plus 11, does it equal -8 squared plus 4 times 8 minus 7? I'll let you do this. Just make sure when you do this here, you square this first and the negative is going to stay in front. Okay, so you're going to see if these two things equal each other. Find the limit if it exists for cotangent of pi. Okay, let's talk about cotangent. Pi is over here, -1, 0. Cotangent is x over y, so it'd be -1 over 0, which doesn't exist. Again, a number over 0 is no. So we're going to write T N E. There's an asymptote, but if you remember cotangent and tangent on your trig organizer, you can look at that. Tangent looks like this, and cotangent is like that. So they have all these asymptotes. So sometimes you're going to, it does not exist because they're not continuous functions. Unlike sine and cosine. Sine and cosine are both a wave that are continuous. Let's move down. If I plug in 3, you get natural log of 0, which does not exist. So you have to plug in something close to 3 from the right. This is going to be a number that's close to 0, but a positive, really small number. And so if you look, natural log is like this. The natural log of x minus 3 has just been shifted right 3. So this is at 1. So if I shift it right 3, 1, 2, 3, this would be at 4, okay? Which means that its asymptote is at 3. And as I go to 3 from the right side, I'll be approaching negative infinity, or you write does not exist. The infinity describes what happened, but technically the limit does not exist when you have infinity. Let's see, find the limit if it exists. If the answer does not exist, enter D and E. So if I do 5 over 5 minus 4, I'm trying to see if it'll let me click here to begin. I don't know if it'll let me if I'm the instructor. Whoops. Where did it go? Okay, now it changed. Okay. So if I plug in this 9, I get 9 minus 8. That is the square root of 1. So I get 9 over the square root of 1, which is 9. And so that does exist. The natural log of 9 exists. So let's see. Find the continuity here. F is discontinuous at x equals. Okay, to find the discontinuity, that whole removable versus non-removable section, you factor, if you can, the top factors to be x minus 1 and x plus 1. And we see that I can remove this discontinuity. So it's a removable one because you can cross it out, which means it is a hole in the graph. And it's a hole where this equals 0, which is at x equals -1. So that's that answer. And you can see that, you see the hole, it's a removable discontinuity. This one, discuss the continuity, let's see. Is it discontinuous? Well, if I plug in, first let's talk about each of these are fine. They're continuous everywhere by themselves because they're polynomials, because the power on x is a positive integer, all right? So that means they're both continuous everywhere. But my question is, are they continuous where we hand off? And we hand off where x equals this number here, which in this case is 0. So do these guys equal each other? When I plug in the place where they change which in this case is 0 because that's the handoff point. And if I plug in 0, hopefully you see that it's going to get u2 equals 2. So it's continuous because the limit from the left equals the limit from the right. So that's that. Find the value of x which f is not continuous. So that's always continuous because cosine is continuous and 3x is continuous. So if you add or subtract them, they're continuous. Those are those properties of continuity. So since both of these functions are continuous by themselves, they're continuous when you add or subtract them. So this would be none. Now this one on the bottom, however, is it's called a rational function. A rational function is, I know that looks like a scary word. Rational function is a ratio of function. So it's like you have a function on top and a function on bottom. And the issue on there is anytime the bottom equals 0. So in this case, I could factor the bottom to be x minus the square root of 9, 3 times x plus 3. So I have two non-removable. I can't cross out either of these. So both of them are removable. So this would be x equals 3, x equals -3, and both are not removable. Goodness, having a hard time with that word today. Again, this one, same idea, factor top, factor bottom. So we got x plus 3 on bottom, you have x plus 3, x minus 4. In this case, you can remove this one and not this one. So x equals -3 would be your issue. X equals 4 is your non-removable. And this is your removable. And again, that means that this is a hole and this is a vertical asymptote in the graph. If it's continuous, okay, plug in 4 into both places, see if they equal. Plug in 0 into both of these, see if they equal each other. Remember the natural log of 1 is 0. Where's this function continuous? Okay, so you have to think about the domain here. This function only exists when the inside is greater than or equal to 0. Okay, so you already have a restricted domain. And then since this is a ratio of two functions, this bottom one here cannot be 0. So in this case, it's only going to be continuous where x is bigger than 0 because I can't actually equal 0 since the square root of x is on the bottom. So I would say it's continuous from 0 to infinity, which is its domain. Domain is the x values. Basically, what can x be? This one, again, you have to think about where would I have an issue? Since you have a square root, you cannot take the square root of a negative number. So this inside needs to be greater than or equal to 0, which means x needs to be greater than or equal to -1. So you would say from -1 to infinity. Okay, so anytime you see at least 1 0, that means the intermediate value theorem. First, you have to ask yourself, is f continuous? This is continuous because this is continuous, 2 is continuous, and cosine is continuous. So if you add or subtract continuous functions, you have a continuous function. So all you need to do is plug in 0, see what you get. Plug in pi, see what you get. So if I plug in 0, I get 0 minus 2 minus cosine of 0, which cosine of 0 is 1. So you get -2 minus 1, which is -3. And if I plug in pi squared minus 2 minus cosine of pi is -1. So pi squared minus 2 minus a -1 would be +1. Pi squared minus 1. This is close to 9 because pi is 3.14. So bigger than 9. Minus 1. That's a positive number. And this is a negative number, which means I must pass through 0 because I'm somewhere below 0 and then I'm somewhere above 0. So I have to cross through 0. So I'm going to see because f of 0 is less than 0 and f of pi is greater than 0. So yes, it's that first answer for my example. That's very similar to what we just did. Again, very similar to what we just did, except they want you to find it. So verify it's continuous, and then it basically it wants you to figure out where it's true. So this one says find the c. So basically set that function equal to the output they want it to be. So set x squared plus x plus 1 equal to 7. So if I solve this, x squared plus x, subtract the 7 over, that would be minus 6. That would be x minus 2 times x plus 3. Because if I do this, I'll get 3x minus 2x gives me this x here. So that means I have x equals 2 and x equals negative 3. I want the one in between 0 and 7. So that would be x equals 2. C is an x value. Okay, it's just that particular x value that when you plug in 2, you output what they said here, 7, which you can check it. 2 squared plus 2 plus 1, is that 7? 4, 5, 6, 7. Yes, it works out. Verify it works. If so, find the C. So again, you're going to set this equals x squared plus x over x minus 1 equals C. In this case, cross multiply. So you get x squared plus x equals 6 times x minus 1. So distribute this guy. So you get x squared plus x equals 6x minus 6. And then I want to get these all on one side since it's a quadratic. So I'm going to subtract the 6x and add the 6. So x squared minus 5x plus 6. And then I'm going to figure this out. That would be a minus 3 and a minus 2. Because I want a positive 6 and a negative 5 when I add them. So that gives me two values, x equals 2 and x equals 3. I have to pick the one that's on this interval. So 2 is 4 halves. So 5 halves to 4, the interval would include the 3. So hopefully that helped you guys with the assignment. Again, reach out to me if you have specific questions. I'm here to help you.